In our first video on matrices, we learned the basics of how they're set up and how we can add and subtract them. We also did scalar multiplication. Here we're going to do the multiplication of two matrices, and it's going to be a little bit, quite a bit more complex. Now, what we're going to see here, here's the point. What is going to be true is that multiplying a times b is not commutative, meaning you can't simply just turn them around and multiply the other direction. And so I'll explain why that is in just a minute here, but that's the point of this slide. Okay, if we're going to multiply two matrices, here's what's going to happen. What we wind up doing is we're going to multiply a row times a column. So what we're going to do here is this first row is going to multiply this first column, and it's going to make one entry. So 1 times 5 is 5, 2 times 4 is 14, and then we add that up to create the one value that will be in the new matrix. We then do it again. We do row times that next column. 1 times 6, 2 times 8 is 16. We add that up. We've got the 16 plus 6 is the 22. Then we move down. We go this row times this column. We get 15 plus 28. That's where our 43 comes from. And then finally this one times the final column. So it's row times column. Now, one of the things, this is going to be kind of easy to see here, but the way that this matches up, we're going to need that the columns of the first matrix are going to need to match up with the rows in the second. So you literally write them like this. If I've got a 2 by 2 by a 2 by 2, we need these to be the same. If this matches, then it tells us we have the same number of entries that when we multiply through. So I've got two columns and two rows are going to make sure that that matches and when I do my multiplication. So let's see here. When I do, I'm going to have these two columns will go by the two rows. Let me go forward and let me see if I can find one. Yeah, here's a better example. So first of all, let's do our multiplication here. So if I do a times b, I've got a 2 by 3 being multiplied by a 3 by 2. Now remember, it's rows and then columns. So this will match. Now let's go through it and I'll show you why. So we're going to go ahead here, and so what we would do is this row, it has 3 entries because there's 3 columns, right? 3 entries because of 3 columns. Now when we multiply it by the second, we have 3 rows. So do you see why this is necessary? We have to have an entry to match up with each of the cells. So cell 1 has to match up. So one more time here. We have a 2 by 3, which means 3 columns will then multiply by the 3 rows, so there's matching entries. But other than that, it works exactly the same. We do -1 times 5, 2 times -4, 3 times 2, and all of that will then be added up to create that new value in that first cell. We would then do it again. This row times this column, -1 times -1, 2 times 0, 3 times -3, or 3 times 3, add it up, you get 10. So if you're wondering where it goes, I remembered thinking this myself when I was learning about it. So if you're doing row times column, where those would overlap would be in this cell right here. Like if you think about this, like you're doing this row and this column, where you'd have, if you put them together, where you'd have a matching loop would be right here. So this row times this column is going to create this cell. This row times this column would match up here, is going to create this cell. I hope that makes sense. So row times column, row times column. If you thought of them overlapping each other, that's where it's going to create the new value in the new matrix. Okay, so now we're doing b times a, so we have a 3 by 2 by a 2 by 3. This will work, but it's not always the same. So this will work because the inner part will match. I've got a 2 and 2, so that's going to work. 2 columns, 2 rows, so everything will match up properly. So we could go ahead and do it. So they're going to walk us through here again, just like we did. Row, column, row, column, row, column. So, and we create this. But notice, look, this is the point here, that if you multiply a times b, you don't get the same value if you go the other way around. B times a is not the same value. So in other words, so 2 times 3 and 3 times 2 gets you the same thing, but not in the world of matrices. That's not necessarily true. Okay, so we're going to just work an application here where we've got, this is, I don't know what the story is, it came out of the book here, but each of these two teams, I guess, needs to buy this equipment. Wildcats need 6 goals, 30 balls, 14 jerseys, etc. here. Now, by doing this in matrix terms, we could say that here's the cost of each of those items. So we've turned this into this cost matrix, and here is the necessary equipment. And by making this a 1/3 matrix for the cost, we could then multiply it by the, I should have done 3/2 matrix, and we have that matching inner connection here. The columns and rows match up, so we have that matching connection, and so then we could go ahead and multiply. So this will work, and when we do this, we'll be extending that cost to both of the teams. So I think we've got it worked here. We're doing the cost of the equipment by both teams being placed into a single matrix. We multiply this through, and we're going to get the costs for both of the teams, the total costs. So this row times this column is going to get us the total cost for the Wildcats. This row times this column is going to get us the total cost for the Mudcats. Okay? So, oh, we got more. I thought we were done. Okay, so how about several operations together? We're first going to do the A times the B, and then we'll do the C. So we've got to do a 3/3 times a 3/3. All this wanted to be done on a calculator. So if we did a 3/3 by 3 ourselves, we would multiply that through, and then we would subtract. Now, I don't know what's coming here. I may need to do a whole video on how to enter these into the calculator, but it's pretty straightforward, and it'll say in the book, but above matrix, if you've got a TI 83 or an 84, or above X inverse is the matrix button. If you go in there, you can move over to, along the top, you've got name, math, and edit. If you hit edit, you can then define the dimensions of a new matrix. Now, you can't get them to clear an old matrix unless you delete like all of your memory. It's difficult. But so you can define the dimensions of a matrix, and you have to hit enter on the screen after everything that you do. So here I'd be entering a 3/3, and then if you hit that, now you're down in the matrix where you've got 3 rows and 3 columns. You can literally enter in every one of these values, but after every one, hit enter. And don't forget, if you use a negative sign, not a subtraction sign. Okay, once they're all in, hit second quit out of that screen. And again, I might show this with an emulator, a calculator, a fake calculator. Once they're all done, if you go back to matrix, just hit enter. If you can multiply A times matrix B, and it will do it for you. Now, if you try to multiply 2 matrices, it'll give you an error if their dimensions don't match up properly. But so if I entered this as A, B, and C on my calculator, just took that time, then on the front screen I could do matrix A by going into matrix, under names, hit A. Then times, go back into matrix, go to B. Then subtract C, and you would get the answer that they've got here. Again, this is telling you how to do it here. And I think everything I said is probably all you need. But again, I may supplement this with a video. But pretty straightforward. Just enter this into matrix A, this into B, and your calculator can do all of it for you.